Okay, this is the lecture right before the last lecture. So there are 2 more lectures left. And the topic today that we're going to be covering is creating classes, which is based on chapter 11 materials. So since today there's no student, it's going to be a bit boring, maybe. Classes is the keyword of today's lecture. And what are classes? That is the purpose of today's lecture. And other objectives include understanding what classes and objects are in Java. How do you declare them? How do you use them? If you remember, classes in this class by definition are composed of 2 things, and those are methods, which are behaviors, and data or attributes. You should by now remember what constructors are, okay, how they're different from other methods, and the constructor signature, which differs from other methods as well. And lastly, knowing how to use Java API and SDK correctly, that is also something that you should by now know, now that you've been exposed to classes. Anyway, without further ado, let's review just a bit classes and objects. So now we have 1 student in the class. The lecture is about to get a lot better. Hey, Siriwat. All right, classes and objects. So consider this private tutoring. Classes and objects. First, all classes are non-primitive data types. In other words, all primitive data types are not classes. What are primitive data types? Such as int, float, double, char, right? And we've seen from our class that non-primitive data types, on the other hand, are such as string, right? Or your own classes that you create, which we have seen plenty from in this class. And when you hear the word instantiate, what does that mean? That simply means you are creating objects from the class blueprint. So every time you declare a class, that is the blueprint, and every time you new, right, the keyword is new. When you new a class, you're essentially instantiating objects, okay? So this is why we say that an object with no S is an instance of a class. So now that I spot that typo, I'm going to fix it right now if I can. So hold on. Okay. So that is, whoa. Again. Right, so now it's correct. An object is an instance of a class. Classes and objects, okay? Now, in the previous slide, we were simply showing you an example or the theory, right, behind classes and objects. Now we're showing you a concrete example of what you need to do to instantiate objects. So you have, as an example, my Java box as the class name, and to simply have multiple instances of my Java box, you simply just instantiate with the keyword new, right? And if you remember, when you do something like this, this is actually passing parameter into the constructor. And if you recall, constructor is a special method which has no return type, and that is used to initialize the object that you are creating. Okay? So in this example, we're simply creating two instances of my Java box. One is called, the identifier name is box1, and the other one is box2. Okay? And how are they different? Not only that they are two separate or different objects, but also they have different attribute. One with the attribute of red, the other one having the attribute of purple. Define your own data type, and that is one usage of having a class, right? You are able to define your own data type, right? So suppose that we want a data type that is used to store students' exam scores. How can we use classes and objects to accomplish that? Think about it. So let's just look at the data store, the data type graphically. Okay? How might you store the students' exam scores? Well, if you were equipped with pen and paper, you might write them down in a table like that, a two-column table with ID and the score, right? Well, if that is what you want to do, how can we do that? How can we achieve the same thing using Java? Since you have a list of students, one way might be using arrays, right? For example, you can have an array of student ID as well as another array that stores a list or an array of scores. But the problem that you run into is that how do you relate the student ID from one array to the other array? Hey, I'm so surprised two students with the low midterm scores actually show up. But that's good. Maybe that's why you get a high score on the final exam. Yeah, I saw your friend now, Nick. Yeah, I've signed his paper. He doesn't look like you. I mean, not like the type of student that doesn't come to class. He actually looks like a good student, but I don't know why his GPA is so low.
I'm a good student.
Okay.
Just keep me for the final.
Prove it to me during the final exam. What did you get on the midterm?
22.
Oh, he got 22. That's pretty high. Yeah, that's good. That's good.
Told me you have to recheck it.
Yeah, what did you get?
17.
Oh, not bad.
You have to recheck it, man.
Why? Why do I need to recheck?
I think I get higher than that.
Really?
Yes.
Where's your midterm right now?
Huh?
Where's your midterm?
What?
Where is your midterm?
Where's your midterm?
Yeah, your midterm.
I told you 17.
I know, but where's your midterm? The actual exam.
I don't know.
You don't know? Hey, you can dispute your exam score. I mean, I'd be happy to, if you deserve it, I'll be happy to give you more points. But you have to prove to me why you deserve it. What? I cannot just give it to you.
Can you recheck it for me?
I can do that. You just send me line, I guess. Okay?
My name is Chris. Mr. You just recheck it for me.
But, hey, dude, I'm not gonna remember.
Okay, mine.
Good. Okay. So we're done with our little detour, entertaining detour. So now we're coming back to how to store, a list of students with exam scores. One approach is to have two arrays. We've talked about that. You can have an array of student IDs and you can have an array of the scores. But the problem that you run into is that how do you relate the two, right? It's pretty hard to relate the two because if I access one array, I get the student ID, and then I have to go to another array to access the corresponding exam score for that student. It's kind of cumbersome. And if you did this on the final exam, I can guarantee you that you'll get a 0 point for that problem. You probably don't want to do that, do you, Grit? No? No, that's good. Okay, so now the guy is actually smiling because instead of having 2 separate arrays, okay, now we have an array whose element, okay, where each element actually contains what we call a tuple or an object. An object of what? An object that's composed of ID and score. Okay, do you think this is now a lot easier to store the student's exam score? I'm not asking you guys to smile. I'm asking if it's now better compared to the previous solution where we had 2 arrays. Or are you guys ready to go home? What are you guys doing this weekend? Studying? Do you think that you're ready for the final exam yet? No? Are you? Not yet? What class are you most worried about? This class?
Yes.
Why? You come to class. By the way, I'm going to be creating the problems for these chapters, the hardest ones.
Is this object?
Yeah, this is classes on objects.
What about recursion?
Yes, I'm actually, last week. Yeah, last week. Oh wait, last week or, last week. Yeah, we covered recursion last week. Tadda called it incursion. And they corrected her that it's called recursion. So, why are you worried about this class?
It's freaking hot.
Really? Well, one way that I can help you is that we'll have a final exam review, and I strongly encourage you guys to come because at least at the final exam review, you'll have some sample problems, which if you know how to do, you should be able to, or better prepared for the final exam. So don't spend too much time reading. I think spend more time practicing solving problems probably will help. I can guarantee you that the final exam will not be as hard as the homework. Sorry? Well, my parts, they are the hardest. But by that I mean the concept is the hardest. You know, classes, recursion, objects. That's why I specifically chose those to create problems for those chapters. So you shouldn't worry. You shouldn't have to worry. Okay? Anyway, so do you agree with me that rearranging the data this way is better than this? So this one or this one is better. Siriwan? Which one? Why?
Yeah, so it includes the both ID and the score of that ID.
Right, exactly. So the key is that you group the related data together, right? And because they're together, it's easier to access. What's your name? Sitipum. What's your nickname? Ted. Net. Net. Then why do you think this is better?
Because it has score.
Okay, that's a good answer. Then I ask you. This one has score too.
It has 2 arrays.
Okay, so why is having 2 arrays a bad thing? You can help grid. Too much space? Really? If you actually count the number of squares, right? You have 6 here, 6 there. That's 12, right? This is 6. You might think that that's actually less, but each cell has 2 rows. So that's 12 too. So in other words, you have the exact same storage requirement. 12 here and obviously 12 here as well. So it's not about the storage. So why do you think this is better? You said that, hey, it has score. I said, hey, this has score too. So why?
So it's less confusing since the idea is going same place.
Yeah, you could say that, right? It's less confusing. I mean, you have a list, right? And each cell has all the data that you need. You don't have to go to 2 places, right? For example. So what's the point of this? The point is that you can expect on the final exam, I will be giving you a problem like this. I'll ask you, for example, hey, this Ajahn Sivabut is in the process of writing a Java program. And what he wants to do is he wants to store the student's ID and the score. Create the corresponding class that will help him, that will allow him to achieve this, to store this efficiently too. The keyword is efficiently. Does that make sense? So you can expect that you'll be given a problem similar to this. This is why I asked you, hey, is this better? No, this is better. Because your answer, your understanding of this will help you prepare for the final exam. Because if you implemented it like this, where you have 2 arrays as opposed to 1 array, for this one, if the problem was 10 points, I probably give you 2. Whereas if you implement it like this one maybe, depending on how you implement it, I might give you like a 9, 8, or 10. Does that make sense? This is why I'm going through this now to make sure that you understand. And I think Grit, I know that Grit already knows he's a really good student, so I'm not going to ask him. So how do you take from this diagram, okay? How do you convert this diagram into the actual Java code? Well, very easy. This is what we were talking about when we were talking about data type, your own data type. So, what am I talking about? First, do you see here, there's no primitive data type in Java that allows you to store, well, an ID and a score. It doesn't exist, right? What is the data type for score, do you think? If you were to design this program, what data type would you use to store score? Int, right? Because it's just an integer. How about ID? What would you use for ID? Siriwat? What would you use to store the student ID? I'm sorry? Just the student ID. String, right? And this is why, okay, we create the class called what? Student score. And each student score is composed of what? A string ID and the int score. Does that make sense? So on the final exam, okay, you better have your own data type. Create your own data type, okay, which we also call class definition, okay. Do I care about class diagram? Maybe, maybe not. It's not really relevant. But what is the point? The point here that we're trying to show you is that if you put into your Java source code a class like this, if you wanted to create a corresponding class diagram, this is what the class diagram would look like.